going to talk through how to implement a OHLC chart in ClickHouse. That stands for open, high, low, close. You may be familiar, these are used in the finance world. They look like this. So here, if I look at hourly level, we have one candlestick for each hour. So 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock. And each candlestick is, it has an open and a closing price, and then the high price in the period and the low price in the period, which is where the shape comes from. The green ones are where the price has gone up, and the red ones are where the price has gone down. I can look at different kind of buckets or aggregation levels. So at daily level, this is at midnight. This is the 9th, this is the 10th, this is the 11th, this is the 12th. I can drill down to 4-hour blocks, so 4 a.m., 8 a.m., 12 noon. I can look at hourly, as we've seen, 9, 10, 11, or 15-minute buckets, or 1 second. So this is all about the kind of aggregation granularity. If you notice as I move between these, it's super fast, and I suspect that's because Binance are doing some pre-aggregation. So depending on which granularity we look at, we get a different OHLC time series. So I've implemented something similar over here, and this is running against my ClickHouse instance. If I look at hourly data, so this is 17th of Feb at 1 o'clock, this is a candlestick, and 3 o'clock, we have this one. I can also move between the different windows, so this is 15-minute, 10-minute, 5-minute. So you can see that changing between these is also quite fast, and that's because we're hitting a different pre-aggregated table in ClickHouse. So how is this implemented? I'm going to run through it step by step and talk through the schema. So I'm going to start by dropping all of the tables, and just to show now I've done that, we're going to get an error because the table doesn't exist, to show that the application is connected to this ClickHouse cloud instance. I'm going to create a table to hold my base trades. So this is a raw and aggregated data, and it has a symbol, a price, a volume, and a time. We're then going to create a table for the aggregated data. So this is the 5-minute aggregation. And I'm going to create a materialized view that every time I insert into trades, I insert into this 5-minute bucket. Now I'll call out a few things about this. Every time we insert a batch of data into trades, I'm going to round down the timestamp to the start of 5 minutes. And the idea is that I'm bucketing all of the trades into the nearest 5-minute window. I'm also using an aggregated merge tree. So what this will do is if I have 2 trades for BTC USD at 12.17, they'll be rounded down to 12.15, and then those rows will be collapsed. And we will calculate the min, the max, the sum, the count, etc., taking into account the fact that we need to merge those 2 rows. So you probably need to read up on aggregating merge trees and what they do for us, like the kind of state combinators and stuff. It's slightly tricky to get your head around, but it's something that's going to help us reduce the amount of data. Then I'm going to do the same at 10-minute granularity. So create the table, create the materialized view, and then at 15-minute granularity. Now if you notice, all of these tables, all of these materialized views, they listen to our trades table directly. What you can also do is kind of daisy chain them. So I have a materialized view that listens to my 5-minute table, which populates my 15, and then a materialized view which listens to my 15, which populates my 30. I think the amount of work is the same on both of them, so I've implemented both successfully. So then I'm just going to create all of these as a batch rather than do them individually. So we go up to 24-hour data. Now what I would expect is if I insert, say, 4 days worth of data, in my 24-hour table, I should have 1 row of data per symbol, because that's what we're looking to do. We're looking to reduce rows and make it easier to query at less granular resolutions. So we've created everything now. I have all of the tables and materialized views. I'm going to go and insert a bunch of trade data into my base table. So, sorry, this is quite hard coded. I think it spans 3 days, so 17th, 18th. I think the 16th to the 18th of Feb is in here. So that's been inserted. So then what I'm going to do for all of my different tables that I've created is take account of how many rows do we have in each of them. And this kind of decreasing number is encouraging. So you can see that I've inserted 800 rows into my trades table, but when we've bucketed them into 5-minute windows, they landed in 488 unique kind of 5-minute window buckets. When we rolled up further to 10-minute buckets, there was only 269 observations, 181, 47, and then we hit 17 3-hour periods and 4 24-hour periods. So that's encouraging. That appears to have done what we expected. If I flip back to my demo app temporarily and hit refresh, then the data is back. So this is our 30-minute buckets, this is our 1-hour buckets. You can see we have fewer observations. The 3-hour we have even fewer observations, and at daily level we only have 2. I'm not sure why there's 4 rows in the table, maybe something related to mergers or something, but yeah, we've got data for the 17th and the 18th. So let's go and look at what's actually in these tables. So the 5-minute candles, sorry, just a typo there. The 5-minute candles, so 5, 15, 20, 30, 35, 40. For each one of those windows, we have an open, high, low, close, and a total volume and a count. At the 15-minute aggregation, you can see everything should be in 15-minute windows. And then if we go and look at 24-hour level, let's see why we have 4 rows in here. Oh, it's collapsed down to 2, so yeah, I think it's something to do with mergers. We've got 1 for the 17th, 1 for the 18th. And all of because we're using aggregating merge trees, all of the semantics around open, high, low and close are maintained, and same for the count and the volume. So yeah, aggregating merge trees are quite kind of fundamental to this. So if you want to do this, I'd kind of recommend that you really understand aggregating merge trees. But then what we're doing is using these different tables to hold data at different granularities and materialized views to populate them on each insert. When that's done, then we can build a nice kind of snappy user experience like this over very large quantities of data. So yeah, hopefully that's helpful. I'm going to write a blog post on this on my website and include the code. So yeah, please reach out if you need help doing something similar.